I'm going to continue with the second example of how to find the inverse of a function once you have a restriction. Here I have my f of x, my function, which is x squared minus 4 times x plus 7. And here I have my restriction, x greater or equal than 2. Now, starting from that, I want you to notice something here. I already have here the graph of this function on the right side. And I want you to notice this. All the values, just by restricting the values of x to all greater or equal than 2, we are also restricting the values of y. And here, all the values of y, we can see are all above the number 3. So I'm going to add this condition here just right after the restriction of the domain here. Y is greater or equal than 3 now. I want you to keep this in mind, and I'm going to continue with this, the actual process of getting the inverse of this function. Here, I'm going to start here by substituting the f of x for y here. Y is equal to x squared minus 4 times x plus 7. Here comes a part here, a funny part here, because we have, in order to proceed, we have to complete the square. We have to use this technique of completing the square, and that's what I'm going to do here. I'm going to do it just the way I teach it, so if you want to do some other way, just feel free to try it here. I'm going to start by taking this number 4 here, going to put it outside here, and I'm going to apply this operation. I'm going to divide it by 2 and square it here. So this 4 over 2 is equal to 2 squared, and this ends up to being a 4. Now I'm going to what I'm going to do with this number 4, okay, I'm going to place it in here, in this expression here, x squared minus 4 times x, and I'm going to place it here, this 4, which is a positive 4, and then I'm going to place it with this negative 4 here, just after the plus minus 4, positive 1 and negative 1. Now why I'm doing this, because by adding this positive 4, negative 4, it's just like if I would be adding a 0. That is, I'm not affecting the original statement here that we started at. If I would just be adding this positive 4, I will change completely the original statement, and that would mean we'll be dealing with something different. We cannot use these equivalences here. So I'm going to continue now. Okay, I'm going to write it down here. I'm going to write it like this: x squared minus 4 times x plus 4, and now I'm going to add up these two terms here, the last two, like this, plus 3. I'm going to leave the first 3 untouched, and that's here's the reason why I'm going to do that, because these three guys here at the beginning, and these first 3 terms, these 3 guys are already a perfect square. That is, they fall into this structure a squared minus 2 times a times b minus plus b squared. And every time you find this structure, you can factor this out like this: a minus b squared, just like this. So, and that's what I'm going to do with these first 3 terms. I'm going to write it just right here. Going to be x minus 2 squared plus 3. Now up to here, I just complete the square. Now this is just a intermediate step. I'm going to have to continue because my goal here is to find a solution for x. So I'm going to continue with that. I'm going to isolate x. From here, I'm going to subtract 3 on both sides of the equation. I'm going to get here y minus 3 is equal to x minus 2 squared, and I'm going to take the square root on both sides of the equation, and that is, I get the square root of y minus 3, it's equal to x minus 2, but I'm sorry, it's too ugly. Yes, like this. This square root has to be a plus minus here. Now I'm going to add a positive 2 on both sides of the equation, and I'm going to get here, it's 2 plus minus the square root of y minus 3. And now I'm going to interchange the x and the y. I'm going to get here y is equal to 2 plus minus the square root of x minus 3. And here comes the funny part, because we cannot have this plus minus. We can have either the positive one or the negative one, but we cannot have both. So here I'm going to write here the two possibilities in orange here. So it could be y, it's 2 plus the square root of x minus 3, or y it's equal to 2 minus the square root of x minus 3. Yeah. So I'm going to use decimals here to show you which one should be the proper inverse of this function f of x. I'm going to plot here first the negative one. I'm going to plot as well the y is equal to x, and we can see it's pretty, I think it's pretty obvious, pretty evident that this green line, this green graph here, which is the 2 minus the square root of x minus 3, it's not the inverse of the original f of x. So I'm going to plot the other one, here, the positive one, and we can see it here from the graph. It is pretty evident, I believe, that the orange one is just the inverse of the original f of x. So we can say that from here, we can say that this statement is the inverse of f of x. So it's 2 plus the square root of x minus 3 here. That is the inverse of f of x. Now I want to do something extra here. I want to show you starting from the graph, what's going on with the domain and codomain, the values of x and y for this f inverse of x. Notice something, all the values of x are after the number 3. That is to say, this f inverse of x has a domain, this domain is x greater or equal than 3. And all the values of y are all above the number 2. So y is greater or equal than number 2. Now I'm going to write here in the middle. Here in the middle it's f of x. You have here that the values of x are all above greater or equal than 2, and the values of y are greater or equal than 3. And its inverse, the f inverse of x, all the values of x are greater or equal than 3, and the values of y are greater or equal than 2. Now see something, I want you to notice something here. The x and the y values are inverted, they are crossed, just like this. They are crossed here, just like this. This is just a clue that you can use as well to find the inverse of a function. Now I'm going to continue with a third example, and I believe that by the fourth one you will be able to infer something directly. You can infer which one is going to be the right choice, the positive or the negative square root, just by looking at the original restriction. And I think you'll be able to see it. Okay, let's continue. Let's move forward.